So what we have here is a top chord bearing floor truss that has been tested once already and is on its second test. This truss was designed to give a definitive answer to the question, can we begin to predict where a truss will fail? Joint number 17 on the bottom chord at the left edge of the screen was designed to have a joint stress index of 0.95, while the second highest JSI was only 0.49. The first test proved what we already knew, and that the truss failed where we designed it to, so there was no surprise there. Then, the plate that failed was pulled, and the joint was replated with a much larger plate to lower the JSI of that joint and try to move the failure to a different joint on the truss. Joints 1, 10, 13, and 16, with joint number 10 being the top right heel joint, all had the same calculated JSI. And as you can see, joint number 10 failed, which reinforces the possibility of using a QC joint for doing QC, because when we reviewed the QC data for those 4 joints, the joint that failed was the joint that had the lowest strength based on the number of teeth versus the number of teeth required. There are many more factors that go into QC than what was tested here, but the results give a good indication that doing more detailed QC on a critical QC joint and less detailed QC on less critical joints may be a valid QC approach.